Now everything crashes. Okay, so again, from helpers to middleware, this is the guy, bad person. This is a company, pay them, hire them, it's a good thing, all right? It's not necessarily bound to the person. Let's try to do a bit of history first. So we are in 2002, the first web project. This is around where I started. When I started, I was in high school, and first projects. Can you make me a small website? Can you make me a counter? This is the sort of stuff that came up. Everyone needed to have a domain. Everyone needed to be on the web. We had a toolbox, possibly not the best toolbox. It works, but we had a client. We wanted to actually get to the money, and they had no idea what they were doing, and we had no idea what we were doing. But important thing is to be online, have a presence somewhere. Some warnings. Some of these slides include code that may hurt your retina. Okay? So take precautions. If you have bleach, just for later. Okay, so every project starts with this. You have here include functions.php.inc. You always end it with .inc for maximum security. Then this came later. This came later because PHP had register globals. So effectively, everyone has to declare every post or input variable as a global. Awesome. Otherwise, this code doesn't work anymore. But still, this is what we were doing conceptually. So we have a script. This is our business logic. And by the way, as ugly as it is, this is still nicer than what we were doing, okay? Because I'm still splitting things, whereas before it was just like a massive PHP script with everything in it. JavaScript, PHP, MySQL, everything in one script. And obviously nicely and interpolated. So first of all, if the type is purchase and the user type is Coyote, that's our security layer. Comes from the post variables, right? And in that case, we select our products. We take the products from the URL, right? It's the product ID in the URL. Of course, we forgot to do the or die MySQL error. And then we fetch some results. We have credit card validation. Make sure to always post the credit card to your front end. It needs to be in the Apache logs. Then the success is true. The success can also be false. That's something you still see. Yeah. After that, we take the credit card and save it. Of course. I've done this, by the way, ages ago. I've done this. I still have somewhere something like 3,000 expired credit cards. I don't know where. Which is why I can't delete them. I don't know where they are. Maximum security. And then we mail stuff, of course, with post parameters. So this is nicely usable for injections in SMTP headers and stuff like that. Right. But this is our business logic. We used to write this, yes. Then we have a separate file, which is where I'm already faking it. Let's assume we have a separate file called the template. If the success is not set, then we exit. That's the proper way to stop execution of your script. Otherwise, you render this page. Here it looks acceptable. Anyway, this is not nice. But this is what reality is or was. For some people, this is still the reality. I'm sorry, I know that it's true. There's no concept such as security. Security is more of a theater thing. Nobody knows what they're doing. Nobody has any experience. Nobody got hacked. I got hacked multiple times. Learned it the hard way. The point is, projects were easy. People wanted a comment box, maybe. People wanted a counter, a contact box, something like that. That's it. That was the web project. We had no applications doing complex things. Those were written in Visual Basic, which is a different chapter. Okay. The point is, we get the job done. The customer is happy. They're going to get their product. We are going to use the globals to make it work. Things are somewhere. They just appear magically. We rely on them. We push to them. Just put everything in the session, use it in the next page, all of that stuff. Nice. Smells like burnt, but we did this. It worked. What is important here is at this age, this dark age of PHP development, spawned this pattern of having include functions.php.enc. Somewhere in our scripts, there was this line. And this is the birth of what I call the helpers. So what is a helper? A helper is a functionality that is transversal to what you're doing. You're validating a form if you are validating forms. You are doing some SQL assembling. You are doing some technical stuff. You're doing some stuff that is supposed to happen in every page. This is what a transversal concern is. So it's not really the hot path of your application. It just happens to be between you and the success scenario or the failure scenario. And it's just a layer in between. And we smashed all of this in include functions.php.enc, which, by the way, are not functions. They were most likely procedures that were doing a lot of stuff. Chapter closed. Client is happy. Some years pass. The clients will happily pay for maintenance. But at some point, it is very much clear that this stuff is not really maintainable, and they will most likely have to pay for a rewrite. I think every one of us went through a rewrite of an application at some point. This was, let's say, seriously terrible. So a few years later, what happened is that the first frameworks came up. Libraries, frameworks. We, by the way, in the PHP community are quite slow. You know, Java people have been doing this for a decade before we started doing this stuff. It's just, we all learned slowly. We were all tinkerers, just slamming together a web page. It worked. Cool. So the first framework came up, first frameworks. There were very old frameworks, but not very popular. I think Agavi is one of the oldest out there, and I don't think many have used it, for example. So what happens here is that the framework is right. The authors of the framework know what they're doing. We have no idea. We have no idea what we're doing. What I think is most relevant in this age, which is around a decade ago, by the way, is that we start to separate concerns. Things are being put in different boxes, as in who has to do what. It's still a massive amount of mess, but it's getting better. So we started using this MVC term wrong, by the way, because it's not really MVC. It's MVC-ish, because HTTP and MVC don't really play well together. But we started doing this MVC thing. So if you go back a decade ago, every conference was about MVC, 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 framework, 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 separate things, right? They were mostly separating things in layers, technical layers, not really business things yet. But there was some separation. So we had this concept of a controller now. And developers loved the controller. They just put everything in there. So controller looks like this. We now have a purchase controller, which extends a base controller. You always extend from a framework for maximum coupling. Always extend from a framework. Then we finally have a name for what the heck we're doing. It's not just a file floating around, or actions.php with 3,000 lines of code and a giant switch statement. Happens. Well, 3,000 lines of code is optimistic, by the way. Then we have some security. Now we're validating, is it a coyote? Is it allowed to access? Well, we just redirect them back somewhere if they're not allowed to access. So we have this idea of stuff being relatively secure. And then we have this new thing called forms. Form components are awesome on one side, but they're also the most terrible thing in our job. I think that's the one single point where most of the development time and anger goes in. But we have form validation from post variables, not from globals and stuff like that. We can render an invalid form, and it makes sense now. You still have, you know, this value does not correspond to regular expression, blah, blah, blah. And then the user goes like, what the hell is a regular expression? But still better than what we had before. And then we have some logic to load the products and do things on products. And this was the record, the model. Everything was a model after this. We had this fat model, fat controller idea. And we have a separate rendering engine with different templating and stuff like that. This is good progress. If you look at it now, where you're supposed to know 20,000 technologies and perfect them all, assuming you know them all, it still looks like crap, but it's still progress. So what happened in this age is that a lot of awareness was raised around security. So who here learned the CSRF from a framework? Who here knew about CSRF before using a framework? Seriously, I think you lie. I don't believe you. A lot of people, by the way, learned of CSRF just because there was documentation in a framework about this CSRF thing, about this attack vector in first place. XSS relatively, I wouldn't say solved, but the frameworks now provide tooling for dealing with it. We have validation for forms. We no longer have SQL all over the place, in theory. But we got rid of a lot of security sensitive endpoints mixed together. We still heavily rely on these helpers. So here, this is Coyote, and this is not allowed. So what happened is that either we had a base controller with all the methods in it, or we had something magic, but this is how we dealt with cross-cutting concerns. So our framework gave us some sort of infrastructure to plug in new methods. And this was usually done like this. You have a base controller. The controller has a magic call, because PHP magic at the time was awesome. Everyone said, let's use it. The language has it, let's use it. Terrible idea. And then you have this helper registry. You get some helper by name, statically, and then you call it with some arguments. That's it. That's how it was implemented. Zen Framework 1, anyone? Right. It worked. I still have applications that work on it. I wouldn't say it's fun. This is broken. Don't do this. So we still have registries. Registries are not much better than globals. They're still a massive pile of stuff laying around there. They're still global, which means that it's state that you rely upon and that can change, and you're going to have bugs there. And then you still have stuff like this. I'm not going to say where this comes from, but maybe somebody recognized it. So you have like a static call and a singleton somewhere, and then you call some method, right? Just a tip, this is not from 2007. People still do this. Don't do that. Stop. Please, get some help. And also users at that time were still slamming everything in the controller. You still go into an application developed around a decade ago. It's controllers and helpers and magic all over the place. It's getting better, but we're still there. We still have this massive amount of coupling with the framework. And coupling with the framework means that if the framework changes, your application changes as well. Big problem, because your application's money does not depend on the framework's decisions. It should not depend on it. We have this singleton, so everything in one location, and we have conventions. People loved conventions because at the time the rage was Ruby on Rails. Nowadays, everyone says that Ruby on Rails is possibly not such a good idea, even in the Ruby community. At the time, everyone wanted to emulate it, so you just put a file in a directory and magically things happen. Bad idea, because conventions are hidden rules that are difficult to introspect, and when these rules change, your application breaks in difficult to introspect ways. Stop using conventions. Don't rely on conventions. Use static types, use coupling, use cohesion. Don't use conventions. So in this case, we had this zero-argument constructor thing, where every helper had to fetch things from somewhere, but it could never have constructor arguments, because that would break all the helpers. Autoloading was used as a service location, so based on the name of the helper, you would get a class name from somewhere, and automatically it would go and do stuff. There are still people doing that. Don't do that. So, if you try to do testing, which was the new rage, by 2013, 2014, I would say, people started to really go into testing. If you're not doing testing, that was 5 years ago. Okay, get on with it. But it wasn't fun. Then we evolved again. We have another iteration of frameworks. 2011, 2012, this is around the time when Symfony 2, ZenFramework 2 came out. And we got rid of most of these problems because we now were aware of them. We could understand that there was something wrong with this stuff. And therefore, we wanted to eradicate it. And effectively, what happened is that a lot of people liked it, and a lot of people said, oh, you're doing everything much more complicated because you didn't experience these problems firsthand. So a bit of evolution, a bit of complexity added. Still, progress, in my opinion. So now what we have is we have our purchase controller. Extend some base controller. We still extend from some controller. We didn't get rid of it. I don't know why. I think it was marketing purposes at the time. You extend from this and you still get a lot of helpers. Bad idea. But now we have state. Look at that. We got properties here. And those are services. We got, well, effectively an explicit link between our code and the code that we want to rely upon. We got dependency injection. So things now go to this constructor thing, which is new to PHP developers. And we started depending on it. And it was relatively easy to see when something was broken because of this. And the code is now statically analyzable. There's no magic methods anymore. All of these are now operations that depend on the state of the object. So now instead of using a magic this is Coyote, we use a this security check, assert is Coyote. There's still some global state hidden in there, but it makes it a bit easier to grasp what is going on. We have an injected form, we have an authentication layer, we have some products repository, we have a notification system. I think this is still progress. There's still a lot of coupling with the framework. So the framework can still break how this stuff works, especially if you extend from it. So there's still this risk of having an upgrade becoming a rewrite. It is getting better, but if you go outside in the wild, what you see is not code like this. Okay? So you go to first Symfony 2 applications and everything is fetching stuff from a dependency injection container at runtime. It took a lot of time for people to understand how to write things a bit better. This talk is not about how you write things better, right? We've been banging on that for years now. Please go back and watch very old conference talks, because this stuff is already explained. We shouldn't explain it more. I mean, we should, but I'm bored. This was also the age where we had the rise of dependency injection as a pattern, big D. We had test-driven development. People were banging on test-driven development. As I said, 2014, around that age, every conference talk was about testing. If I see another PHP unit tutorial by Sebastian, I'm going to hang myself. That's too much. All right. We got ORMs landing in. Good, bad, up to you to decide. And we got this DDD thing coming up. DDD was already quite a thing in the Microsoft community, but the PHP world started catching up with it. So some time passes. So we got this age of frameworks from 2012 onward, and then we have another evolution. I think, at least it's an evolution, which is this middleware thing. And effectively, what we are doing is HTTP stuff. Let's be honest, we don't really write a lot of console applications. We don't write a lot of long-running tasks. We don't really care that much for async, I would say. Yes, there are some people in here that would like to rage right now. So I stole these from HTTP middle world. This is the idea of a middleware. It's layers. Much like in the network layer, you have each layer doing something to your data packet, or in HTTP itself, you have reverse proxies and the network and stuff flying around through layers. So we have the same in an application. So here we have an application around an airport. So you drop your luggage, get your passport destroyed, board the plane, right? Fly, get off the plane. Flying is the actual action. That's the thing that is mutating state in your system. Then you get off, get your passport checked on the other side because they're not paranoid enough, and then get your luggage if you're lucky. And what a middleware looks like is something like this. So here we have a purchase action. Remember that we were saving the credit card and stuff? Well, we're not saving the credit card anymore, but we still do some business logic. So we have our dependencies here, and we have our constructor injection up here. And then we have this action, which receives a request, produces a response. And the action only has its business logic. So get some form data, which is already devalidated form data. It gets some user, which is the already authenticated user. It's not my problem to authenticate the user. I just need to do my job. I'm going to assume that that already happened. And then I'm going to get the product, purchase that product, whatever this is. This is the actual business logic. Send some notification and render something. And the rendering will produce a response. And then instead, we defer anything that is in between to something else. So in this case, we have only coyotes, right? Only coyotes can access this particular endpoint. And only coyotes receives a request and the next callable, which is what to do next, right? So it is a layer between us and the next interaction. And what it does is if after authentication, the user, well, this doesn't make sense. I don't even think that parses, by the way. Cool. Well, if the user, yeah, this is completely broken. Sorry, this is completely broken. Right, so if the user is not a coyote, well, then I'm going to basically render a page and say, not you. You can't come in here. And everything else we just delegate to the next interaction. So we have a bunch of code that is just stopping execution in this case. We have the next action, which is called only authenticated. So only if you are authenticated with this application, you can go forward. And again, it has the authentication layer, renderer, and those are the explicit dependencies. It does the same thing with a request and the next. And in this case, it goes through an authentication layer. From the cookie, it will check if we can find a user. Cookie, not cookie, up to you how you build your authentication there. Dealing with cookies is complicated. Be sure you know what you're doing if you're doing that. If you're not authenticated, then stop execution, produce a 401. So you see now 2 layers, 2 different response codes. Very explicit already. And then we render the next action by adding the user to our request. And then we only accept interactions where the form that was submitted, regardless of which form, is containing valid form data. Now this time we inject the renderer and the form that we want to validate. So, still a bit dirty because of mutable state. There's a very good article around functional form handling. Where's the guy? Yeah, there we go, Marco Perrone. He has made a very good article on how to write a form component that doesn't suck. So what we do here is we take some validity flags and the validated form data. We validate the request with the form. If it is not valid, we produce a 422, which is an unprocessable entity, which is basically I could not understand what the hell you're submitting here. And we produce next with the validated form data. So the next layer will be called with the already validated form data. Otherwise, the interaction stops here. And then we pipe it all together. So you pipe only authenticated users that are coyotes only when the form data is valid, then we produce the purchase form, the purchase action. And this is what you put in your routing definition somewhere. I think this is awesome because it reads well, and each of these 3 steps would be duplicated so many times otherwise. So, I'm a bit of a Haskell nut. Not that I'm very experienced with it, but I would love to write applications with this kind of format, where you just say, you have an application, the application receives a request and produces a response, and that I/O is basically evil things. That means everything can crash and burn, because PHP is like that. You don't know what you're going to get. You know, when life gives you lemon, the lemonade. When life gives you PHP, you're desperate. So you go make a request, you pass it through only authenticated users, only coyotes, only with a valid form, and then through the purchase. This means that this particular bit down here, this purchase, can be tested, verified in isolation. It just focuses on its own problems, not the HTTP stack. So this stuff is possible due to the PSR initiative. I would not call them standards. It's more of, this is our opinion, and it's a good opinion. Feel free to pick it. Up to you if you like it or not. In my opinion, it's a good standard. It's surely better than Symfony HTTP kernel for the haters. But effectively, this PSR7, PSR15, PSR11 allow us to glue together what we previously did with frameworks in a much more composable way, where everyone could pick their own things omakase. If this is going to be a good thing or a bad thing long-term for maintenance, I don't know. I think static coupling will tell us that. The idea is that we don't have a specific framework. This is not Symfony, Laravel's, and framework. This is my decision. I'm just relying on these base abstractions, and those are sufficient. So we effectively managed to kill the framework. The framework, which was our problem in the upgrade path of an application, is gone. And the framework instead becomes just the piping. This is the framework. This pipe function, which you can possibly rewrite in 20 lines of code if you want a simplistic version. It's a bit complex to write, but it's really 20 lines of code, and that's it. It's not more than that. So the framework goes back to framework. It's inside the walls. You don't see it. You can even replace it. It's not really in the center of the action anymore. So you reduce this risk of rewriting, and there's a few nice ideas that were pushed in this kind of age of PHP. Immutability. The PHP engine is not designed for immutability, but our brain is not designed for mutability. When you open your debugger, what are you looking for? Why do you open the debugger? Usually, you open the debugger because you don't know why a certain value has a certain variable has a certain value at a certain point in time in the execution of your system. This should not be a question. If you have immutability, you will get a lot of reduction in this sort of debugger usage. Because things are pure, you just run them, new value, new execution. No longer things changing in place. PSR7 implements this for request and response objects. It's not perfect. It still has this wonky stream object thing because PHP has to use streams for large stuff. But we now have values. We push around values. To make a simplistic example, here's a value object for a user identifier. A user identifier is not an int, because the definition of int includes 0 and includes negative numbers. Those are not valid user identifiers according to our decisions. So what we do is we create a user ID. It's a final class without interface. That is by design, by the way, because you don't have a separate alternate definition of what a user ID looks like. And you can now type hint against that, because you know that this thing can only be built when this number given to it is positive and non-zero. It's a very, very simple value object. Takes 2 minutes to write, less maybe. Okay, 3 minutes to test once, and then you type hint against it, and you have it. And it's an immutable value flying around your system. So this is very useful when you have signatures like this one. You have check password, or the password verify function from PHP core. I can't count the amount of times where I just swap the two parameters and nothing would work, because it's a string. That's not useful, but if you have a clear text password and a password hash, you're not going to be able to confuse these two. The types click together. And if they're immutable, you know that you can avoid a lot of bugs. We now got static analysis coming from PHP stamp, SOM, and Exacat is more of a, let's look at this code base and let's figure out if I need to rip off my hair now or later. That's what Exacat says. And these tools can tell us if the code is wrong before even running one line of code, which is something that compilers have been doing for double my age. You know, so we're just late to the party. Maybe sometimes we'll get generics. Maybe you saw what I did there. But so immutability leads to the next step, which is functional programming. Things just flow through functions. You no longer change things in place, but you have these functional patterns that allow us to compose functions together. This entire idea of piping things together is because each of these building blocks is just taking something, producing something new, and passing it to the next layer. This is why it works so well. So in functional programming, well, since we are in functional programming, that's a little quiz. A class with a construct and an invoke in PHP is a question mark. Who knows that? How do you call this? It's a class with a construct and an invoke. What is it? It's a callable, yes. More precisely, well, closure object, kind of. Curried function. It is a curried function. So you have a function, and you gave it some constructor parameters, which is just some context that is useful for the execution of this function. So this is a function where you already removed some parameters. So let's skip the Haskell thing. You have a register user which receives a database object and a create user, which is some sort of business logic somewhere. And then you have an invoke, which is the user data, which is the information you need to process in order to create a user. It's just a packet of data. This is the same as writing register user with a database, create user, and user data. Right? It's the same thing. So currying says that our constructed instance is a curry of register user given the database and create user. So if you take construct and invoke, and you only have these two methods, all you're doing is functions, effectively. Okay, you still have side effects and stuff, but it's very close to it. So we are pushing functional patterns hard, in my opinion. It's a good way forward. And we can push them also to the storage. So what's happening now is we have this idea of event sourcing. I'm not sure if you already followed something of event sourcing. The idea is that something happened, you don't mutate state, you produce a log entry that says state changed from A to B and give it a name and a label. And you say why it happened. This is it. So you don't mutate state, you produce new events. So effectively you have a list of events, which is the past history. You have a command which says, what do we want to do? And then you are going to get a new list of events, which is what is the new state of the application. This could possibly be the death of ORMs. I think that this kind of approach is much simpler. It looks more complicated because not a lot of us have approached it. But I don't use Doctrine myself for this stuff anymore. If I have complex business logic, this is simpler than having a massive ORM that magically handles all your objects and you don't know when stuff is saved and so on and so forth. ORMs still have a place. They're still very valid for a lot of use cases. But pushing functional patterns is extremely powerful when it comes to composing things in a more maintainable way. So now we can pipe everything. Let's put everything we discussed so far into one massive pipe. So we have this application. The application takes a request, produces a response. The application, loads the request here somewhere. And then we route the request. So anything that matches the purchase endpoint with the post HTTP method, only requests that are authenticated get piped to, only requests that are coyotes, and that gets piped to only with the valid form data. So far, so good. And then we convert our form into a business interaction. So we translate the form into a command, something that we understand from business perspective. And then we load the history from the database, which is the list of everything that happened in our system for this particular user or for this product. And then we perform a purchase, and the purchase gets stored in the database as new history. And we take the new history and convert it to a response, which is telling us what happened. So our response basically says, OK, and this is the new ID example. So we can pipe things together. A few things here. There's no more service location. It's gone. We don't do it. We wired things together before application runtime. We don't have this concept of helper anymore. They're no longer in the business logic. They're outside the business logic, around it. So the business logic is at core, and it is plugged into the helpers, not the other way around, where business logic depends on the helpers, which is a problem for maintenance, upgradability. So anything that is a cross-cutting concern becomes functional composition. We say A, B, and C are pre-requirements for D to happen. Therefore, they need to be piped before the execution of D. And effectively, the if-else logic is just handled through this. We just stop early in the execution. There's a very good talk called Railroad-Oriented Programming, which teaches you how to use functional composition to short-circuit execution to the exit of the application, kind of. We don't have shared mutable state. Well, there's still some, because PHP under the hood has a lot of stuff like read a file and write a file, and that can happen magically. But most of it is gone. So, to misquote Anthony here, I think Gabby here can bring it back home and blame me. Good object-oriented programming is functional programming. If you take the solid principles of object-oriented programming and push them to the limit, you get to functional programming. It's just written and expressed in terms of classes and objects in PHP, because that's how we do autoloading and that's how we do our wiring, whereas functions in PHP are mostly stringy garbage that is really hard to deal with. But it is the way forward, in my opinion. So what's the next jump? I don't know what's coming next. I think pushing these patterns and building more tooling around it, building new syntax around dealing with functions, it would be really cool to have monadic operations in PHP and stuff like that. I say the M word, so I win this talk already. Those are nice ideas, but it is really mostly up to you. I think this is the way forward. It's better than where we were. and there's a lot of space for improvement. So that is mostly up to you now. Now you got a sense of what I think of this, so feel free to, say this is bullshit. The guy has no idea what he's talking about. That's perfectly okay. Come talk to me. We can discuss stuff. But effectively, it's mostly up to you to come up with the next idea and the next pattern that makes the PHP ecosystem more sustainable from a maintenance perspective. Thank you very much.